Oh, Olga is waiting. Hello and welcome back to Calculus 2, section 10.7. This is going to be part 1. We only have time to talk about ratio test, which is very important. We'll take care of the root test and then some of the general techniques and stuff next class on Thursday. All right, so ratio test. First off, do we remember factorials?
Yeah.
No. Yes. Factorials. So this is read as n factorial, all right? Not an n, but n factorial. And it's 1 times 2 times 3 times 4 times 5 times ... all the way to n minus 1 times n. So in this respect, 5 factorial is 1 times 2 times 3 times 4 times 5, which is totaling 120 when you multiply all the numbers. Very important skill that you guys are going to need to do these problems is to peel off extra factorials that you don't need. So if I have, let's say, 19 factorial, but I need, let's say, 16 factorial. That's the wrong way.
They always do.
So 19 factorial is going to be 19 times 18 times 17 times 16 factorial. This. Okay? This factorial. Yeah, I should have used this. So that is very important. This is very important because we are going to use something like this. Okay, so let's go and write our theorem for ratio test, and then do a few examples. Okay, so for our ratio test, we just have summation an. Nothing exciting. It works in multiple cases. We can even use it for geometric series and a whole bunch of other stuff. So what do we have for the ratio? So we are going to take a look at the limit of an plus 1 divided by an in absolute values. That's very important to have these absolute values here. So you must have this. And now, this is going to have 3 possibilities, guys. You have 3 possibilities for answers. One answer is that this limit is less than 1. If it's less than 1, we are talking about convergence, absolute convergence. If it's more than 1, it's divergence. And if it's equal to 1, test is inconclusive, you have to use something else. And those are very annoying situations, because ratio test is one of the dearest and best tests. And I will talk about it, that this is one of the first. You first try divergence test and you immediately go, if you don't recognize geometric, you immediately run to ratio. So, inconclusive. Use something else. Your sheet has other 9 tests, so use something else out of those 9. All right, so ratio test. Let's take a look at a few examples. So we'll put this on a cloud. This is your ratio test right here. And let's make it dramatic. Perfect. All right. So an example of ratio test. So say I'm going to go right in the homework and just do an example. So say we are That's a root. That they did not separate this into root and ratio, so I just have to. Okay, so summation of k squared over 4 to the k, 1 to infinity. Now, by growth rate of functions, I know that k squared is a polynomial, 4 to the k is exponential, 4 to the k is going to destroy k squared, right? It's much faster function. So this is going to converge just because the 4 to the k is so much faster. So this is going to pull it quickly to 0, and we are going to see convergence on this problem. So now this is, again, my experience, right? Because I've been doing this for over 15 years now, right? So I look at this and I know. Now, I am expecting convergence, which means that when I do my ratio test, the limit should be less than 1. So let's take a look at that. I am going to extract ak, which is an, and that's k squared over 4 to the k. Then I am going to create ak plus 1, which is k plus 1, everything squared, divided by 4k plus 1. So every k gets its plus 1. And now all I do is the limit, k goes to infinity, of ak plus 1 divided by ak. So this is k plus 1 squared divided by 4k plus 1 main division. So now we have the limit, k goes to infinity. Yeah, it was a good effort. You know the way to divide fractions. You take the one on the bottom, flip it into multiplication. So we have k plus 1 squared over 4 to the k plus 1 times 4 to the k over k squared. So we flip the bottom one into a multiplication. And now we just have to do calculations here. So I have limit, k goes to infinity. And guys, this is the $1 million move over here. This is 4 to the k times 4 to the first power. You peel it off. This is what's going to create your cancellation. And you just have to take the derivative of the polynomial, which is a joke. So what I have is k plus 1 squared divided by 4 times 4 to the k times 4 to the k over k squared. This is where 4 to the k dies. And all I have to do is to take the limit of k goes to infinity of, I can drop now absolute values. All of this is positive. K plus 1 squared divided by 4k squared. I hope you all of you see it's 1/4 right away, because you have a k squared over 4k squared. Now, what do I know if the limit is 1/4? 1/4 is smaller than 1, therefore converges by ratio test. So this is what it's all about. You have to take this limit. So you create ak, or you have ak, you create ak plus 1, you divide them, and then you just plow through algebra, and then you will get a value that is hopefully either less than 1 or larger than 1. Let's take a look at some of these. So how about k factorial divided by, let's say, 6 to the k, from 1 to infinity. Would anyone offer a solution for this before we actually do it? Would this converge or diverge? What is the gut feeling?
Converge.
Diverge?
Converge.
Converge?
I think 6 to the k is way faster than k. Well,
K is going to get much bigger than 6.
Yes. K's from here get much
Yeah,
larger than
sure,
6 as you
yeah.
go, right? Because this is always
As
6,
you
6,
build
6,
it up,
6.
yeah.
and this is eventually going to be 7, 8, 9, 10.
Yeah.
So the top is going to rise much quicker, so we are expecting divergence. But let's do the magic. AK is k factorial divided by 6 to the k. Oh, by the way, guys, maybe you want to write in blood on this one, that on your sheet over here, that ratio test is the only one when you have factorials around. You see a factorial, it's a ratio test. That's something that should go on your main paper, the one that I gave you, which is all the way third row from the bottom. So if you see factorials, it's ratio test. All right, create AK plus 1. That's going to be k plus 1 factorial divided by 6 to the k plus 1. Limit, k goes to infinity. And now what do I have? I have k plus 1 factorial on top, because it's ak plus 1 divided by ak. So this one, 6k plus 1 divided by k factorial over 6 to the k. Now, I know that you are going to start skipping a whole bunch of steps, which is okay, right? You can immediately peel off k plus 1 times k factorial. Are we all green on this? K factorial has all of the terms up to k. Next term is k plus 1, creating k plus 1 factorial. So if I need k factorial, all I need to do is to peel off k plus 1 term, and the rest are k factorial before that. The same thing on the bottom, peel off a 6, and then leave 6 to the k. Then we have 6 to the k divided by k factorial. Cancel a whole bunch of the stuff. K factorial, 6 to the k, 6 to the k. And you are left with the limit, k goes to infinity, of k plus 1 over 6. Well, that's infinity, which is bigger than 1. It diverges by ratio. It's such a clean test. Such a clean test. You do the limit, you do the peeling, do the canceling, and then now clearly, can you run into a diabolical problem? You have to do L'Hopital rule 17 times? Sure, we can make that happen. But it's very systematic. You have your AN, you create your AN plus 1, divide them in the limit, and just work out the algebra.
Could you end up getting a negative infinity for one of these problems? Therefore, be less than 1?
No, because you're in the absolute value.
Oh, never mind. Okay.
So you're either getting 0 to 1 for convergence, you are getting 1 for inconclusive, or bigger than 1 for divergence. We have time for one more problem, and then we'll deal with the rest next time. So So was this? Oh, this is me making up an example. Guys, problem 21 from your textbook is on the lab. Good luck with that.
Which one? Number what?
Problem 21 from the textbook is on your lab. So good luck with that. Yeah, it's the one with the 2k factorial in the parentheses. So yeah. Yeah, you'll find it. You'll feel it when you get there. It's not gentle at all.
We only have one lab, right? Or two?
2.
5 labs.
4 and 5.
No, I mean, how many more?
4 and 5.
So we have 2 more.
Yeah.
Seems very
How many? Look, the question is, how many physics reports do you have left?
None.
None? Oh, well then we can put another lab for you. You have time. Your time just freed up.
We got one more. Huh?
Physics labs are
15 pages each, I know.
they're. I mean, really, like all you do is just copy what the professor writes.
All right.
He wants it to look perfect.
Of course. Because you're gonna have 2 or 3 of those per week when you go to 4-year school, so like having one over here is not that bad.
I'm not doing another one before.
Yeah, it's just dumb though, because you're just copying everything.
Oh, you're not transferring ever?
Huh? No, I meant.
Because you're gonna have like 3 or 4 of those a week when you transfer out, so good luck. They're not gonna be any shorter.
I don't know about that any shorter. I got friends who were in other schools and they said they're shorter.
Well, I'm glad I don't have to take any more physics classes.
None of my friends in another school had to write a 30-page lab report.
Okay, let's see what else can we find here that it's semi-civil, at least. Most of these problems here are actually root tests, which is interesting. Ooh, this is a good one. Lock the doors. Summation 1 to infinity, negative 1 to the k, k to the k, divided by k factorial. What kind of problem is this? Alternating problem. Now, when is ratio going to kick in? When you take away this, right, and if it passes the tests. Okay. Aw. It's not going to pass the test. K to the k is the boss.
Yeah.
This is the fastest growing function. Ever.
Oh.
K factorial is in front. And then exponential is over here, b to the k. So this is the boss of growth. It's on top, so this is going to... Well, diverge, done. Okay, fine. Well, that was disappointing. When I thought I found something, because I... Oh! Okay, here's one, and then we'll go... And then we go home. 2 to the n divided by n to the 99. I told you to retire your common sense, but what is your gut saying here? Converge or diverge? Everyone is looking at the 99, right? You're looking at 99 and you are ignoring the infinity, so that's always concerning. Like, yeah, $99 is much better than infinity of dollars.
Right, yeah, you got infinity over infinity too.
So we got this right covered. All I'm going to ask you, never think, what's currently in front. Just take a look at that infinity over there and tell me, in general, what's faster, exponential or polynomial? And that's where the whole story ends. What's faster? Exponential. And where is the exponential? Yeah, it's on top, right?
Yeah.
So yeah, it's a little tiny 2 over there, right? And it's a beefy 99 in the bottom, right? But guys, when 2 to the n takes over, and eventually it will, n to 99 will never catch up or be ever remotely as close. Exponential function has the growth that polynomial functions cannot match no matter what exponent you put up there. So just by looking at this, it's divergent because it fails divergence test. Divergence test, you are going limit of an is infinity, it's not 0. So if this problem is on your final exam or exam 3, and you go and you do a ratio test, you will get divergence and you will waste your time. Because if you know that exponential functions grow much faster than your polynomial functions, you will use divergence test here and just say limit an is equal to infinity, which is not 0, diverges by divergence test, and you are done in a single line and 35 seconds. Now let's do ratio test. Let's do ratio test because we are learning mechanics of ratio test. But we already know this diverges by divergence test. So what do? Extract an, which is 2 to the n to the 99, and then create an plus 1, which is 2 to the n plus 1 divided by n plus 1 to the 99. Limit n goes to infinity, and now we have, 2 to the n plus 1 is just going to be 2 times 2 to the n divided by n plus 1 to the 99. I'm just going to skip a whole bunch of steps over here, times n to 99 divided by 2 to the n. 2 to the n dies. And what I have here is limit n goes to infinity of 2 to the n to the 99 divided by n plus 1 to the 99. So technically what I have is 2n to the 99 over n to the 99. The limit is 2, bigger than 0. Boom, divergence, done. But as I said, on your exam, you should be using divergence test, and you look at. So let me actually write that out
Greater
here.
than 1, right? That's important. Greater than 1.
If it's bigger than 1, it diverges. Yeah.
Can you put greater than 0? That's what I was-
Oh, sorry. Yep, I said greater than 1. I put greater than 0. Greater than 1. Thank you. Now I am going to say use nth term test, which is limit n goes to infinity, an different than 0 tells us it diverges. So limit 2 to the n divided by n 99 as n goes to infinity is equal to infinity, which is different than 0, which tells us it's divergent by nth term test. You also call this divergence test on the sheet or so. So, you know, on the exam, I'm hoping to see the blue one because that takes 30 seconds rather than the ratio test. But you see the ratio test works just fine. Ratio test can completely replace your geometric series test. It completely makes it obsolete. But we like geometric series test because we can find the sum. Ratio test doesn't give you sum of the terms. It just says converges, has no clue where to. See you all in 2 days.